Good evening. Coming to you late Sunday night. Sitting here, well, not quite here, just a little further inside the house, drinking my freshly brewed ginger kombucha, realising that I have not been fulfilling on Brain Matrix. And I'll tell you why, because it's been driving me bonkers. It's really challenging. So I figured tonight I would fulfill on it. And I'll I guess talk about some of the videos. One of them, the Fourier Series, is the one I'm going to do tonight. Mostly because I said I was going to do this and I'm going to complete on doing this. Second of all, because I've got to come from this in a different tact. It's challenging. There's trying to find the answer. It's probably not like, by mulling it over my head for hours on end, probably isn't working. Well, certainly isn't working right now. So tonight we're going to talk about why the Fourier Series is really super cool. If you watch, it's a video, I don't know, like 3 or 4 posts earlier. And when I saw this, and when I started to read some of the math about it, I was like, this is phenomenal. And when you're watching the movie, I think it's 3 blue, 1 brown video. So if you're interested in math, 3 blue, 1 brown is, in my opinion, is by far the best at explaining complicated mathematical stuff. And the thing that I loved about it was, and the Fourier series, is that it sounds very similar to the way neurons work. I'm just going to draw on the board here, so I'm going to turn around a little bit. You're going to see me in a sec, don't worry. I don't know why it looks like yellow tonight, so I'm not quite sure what to go with that is. So the Fourier series, as you know, is the addition of multiple circles. So you can imagine, I'm just going to get my trusty toilet paper wiper out here. Don't worry, I didn't use it earlier, it's fresh. You can imagine when you look at it, it's adding a bunch of circles together to produce a more complicated outcome. And the great thing about that is that it's very similar to how neurons work, or sound like neurons work, and it's very similar to how artificial neural networks work, if not right on the money. And essentially what the artificial neural network does is learns about reality and finds a bunch of sines and cosine waves about the thing you're teaching it. Not that we really know exactly how it works, because mostly a black box. You can imagine if you went from here and added this one, and then this one, and then this one, and then this one, on the other side, you'd get something. So let's just say, for instance, they're numbers. So this is the starting point, this might be 1, this might be 0.3, must be 0.5. But if they're waves, you actually get an output wave. And it's very, very similar. It's actually exactly the same mathematics that's used in noise-cancelling headphones. And the way noise-cancelling headphones work is in a very similar way, except backwards. So if you consider there's the headphone, you've got the speaker in the middle, a little microphone up here, and it listens. It doesn't listen to the actual music, it listens to what's going on outside. And what it does is, as the sound from the your little device comes, this is very basic, obviously, comes through to goes to the speaker, any sound that it hears externally, it actually adds the opposing signal, so the opposing wave. And what that means is, if you've got a wave that's like this, and you throw in a wave that's like that, when you add them together, there's nothing. Essentially, you add those two together and they're essentially flat. So even though this wave and this wave aren't zero, adding them together, in other words, hearing it at the same time, means you don't hear anything, which is how noise-cancelling headphones work. Very, very similar to how you do this. So you can actually have very minute, lots and lots and lots of very minute pieces of information saved up, and you add them together and they produce something, just like you saw in the Fourier series. Now the phenomenal thing about this is we all know we've got an imagination. We've also got a great ability to detect reality. So we've got these two things that are fantastic. So I'm just going to wipe this off. Mostly just because, well, nice to have a clean board. But this is a cool question that I pondered with myself when I saw that video, and as I've been, and I saw it quite some time ago, which is that are we teaching, if our brain just worked like that neural network thing, or maybe if you go and learn about neural networks if you wanted to, if our brain was our ability to learn and bring the past and keep it present so that we can actually, not get run over by cars and learn how to do math and, know that, drinking out of the cup is a good idea. How we do that, how do we learn? Is it that we detect reality and remember like millions and trillions and trillions and trillions of little tiny things and all join them together? In other words, we essentially take a snapshot of reality and then work out how to best mimic that. Or, well, I think I just answered my question. Do we use our imagination to try to mimic reality? Or do we actually essentially just remember things like as they happened? So in other words, that this cup looks exactly like this. Or do I use my little Fourier Series ability to add a bunch of waves together to draw like a generic picture of reality? Maybe not so much as pretty as a Monet or as phenomenal as a rainforest or a bird, but enough for me to detect it the next time. Enough for me to make it look like I knew that bird was that pretty, but I never remembered every little intricate detail. And there certainly is people that do that. But it's a very cool thing to ponder, because what it allows us to do is to only remember the things that make a difference. But it's very difficult to be exactly sure how much of the stuff makes a difference and how much it isn't. Because if you want to paint it again, you really need a phenomenal memory. Not only that, but I think most of the people in this group will have done some form of personal. Well, I think everyone in this group has done some form of personal development. There's a view that your past doesn't equal your future or your present. In other words, what's happened in the past does not dictate your future. And for a lot of people it does. And it's probably because of, we're taught that, remember things in school and blah, blah, blah. And a bunch of other things that aren't, the school system's fault or anything like that. That's just the way it is. But it does ponder the difference in that it doesn't seem for us, if we are essentially taking a picture. Now, if I get this is quite a challenge to even explain this. So if we are using a similar thing to a Fourier series to essentially redraw this in our minds, in other words, create a picture of what this looks like in our minds, not the actual thing, but create a picture of it in our minds. The challenging thing with that is that we're never actually detecting reality at all. And yet it really seems to me that this is right here. So it's quite a challenge to see, and I've talked about, well, we all know this when you do personal development, and they say that we're not exactly sure that we can't differentiate between imagination and reality, or we're not very interested in being with the what's so. There's another way of saying we're not really good at being with reality. And I do wonder if this is the reason why. Because for us to remember, we must do something. It's not automatic. It doesn't just magically happen. There has to be some process. There has to be some wired way that it happens, because we all remember. We're all capable of adapting to our environment. You know, rarely do you see someone walk along and just like fall over something they haven't seen before, because they didn't realise, they'd never seen, I don't know, a mattress on the ground before. We're able to adapt. We're able to learn from the past. We're not particularly sure whether I guess I think I answered my question before. I think that what we do is we use our imagination to replicate reality, because it would be significantly more efficient to do that than to take these unbelievably high definition pictures of reality and then process them later. And essentially we just try to copy reality. I should sort of explain something that I talked about previously, which is that we had the experience that out here was a reflection of us. In other words, our ability to replicate out there was directly proportionate to the way our abilities and the way we see the world, and possibly our past, if we haven't actually seen that that's not, our past is not our future, or really means nothing to do with us at all. So it's a very cool thing to ponder. It's not as simple as it might seem. When you first see it, you sort of think, oh, yay. One of the cool things about it, though, is that it's essentially waves. It's essentially sound. So it would probably make logical sense that if we could feel, say for instance, if we could feel vibrations, and then we could hear sounds, and then we got vision, it would be very logical that all those things would essentially be processed by the same neurons, the same mathematics. It would work. We just need a higher processing power. And that's cool, because it actually means that the same thing that we use to hear sounds and learn from sounds is also the same thing we can use to learn from vision. We can sort of hear vision. That's cool. I like that. So thanks for listening. I will be back, and I will be doing this more. One of the things that's bugging me, it's really bugging me, because I've been spending hours and hours and hours, and it's just unbelievable, is that I can't, the question that bugs me is that the answer to this is within us. Like what makes us, first of all, conscious and self-aware is there. It's somewhere in here. I don't know where. We haven't seen to work out where. I've read books and papers, and I've been all over the internet. The rabbit hole goes a long way, let me assure you, around consciousness. And this ability, I was talking about, this ability is, the mathematical proof for one, this thing that has this experience that we exist, and it bugs me that I have been unable to see it. It's here, it's somewhere here, but I can't see it. No matter what I do, I get glimpses. It's like I run a mountain, ran Kurth the other week, and I just have this real experience of nothingness at some point in the run. And I get glimpses, just and as soon as I think too hard about it, it's just poof, gone. So I haven't been coming in because I've been attempting to recreate that moment, regularly. But I will be more often. I've got to discover a way to record. It's not really the words, it's the actual experience of experiencing the nothingness and just being with my own consciousness. There's this blankness. It's like trying to glimpse the singularity in a black hole, is that you've got to look past the event horizon. And once you've looked past the event horizon, you can't come back. It's like the thought, once it goes past the event horizon to glimpse the singularity, glimpse our consciousness, poof, it's gone. It's been driving me nuts. So I apologise. I'm back. I'm still on it. I haven't stopped.